Hey, what's up?
Hey, what's up, bro? Sorry, I was trying to.
Hey, hey.
What's going on? How you feeling, dude?
Good. It was crazy. Felt like I had the flu for a
Was
little
that?
bit, but it's good now.
That was the second one, though. The first one you didn't feel bad.
No, the first one is just a sore arm, like where they put the shot in. But the second one, yeah, that was rough. But
Yeah,
all good
that's what I
now.
heard. Some people get sick. So
Well, you got the day off today or something?
yeah, I had to go to the doctor's clinic to go to the Boston.
Cool, cool.
But yeah, I wonder. I was. That's why I hit you up to see if you want to do it before that way. I
Yeah,
figured
yeah,
I
that
might.
works.
Trying to sign in here to see which one it was.
I think so. Your teacher had to open up the next section, right? It was we weren't waiting for a test, or were we waiting for a
No, we did.
test?
Remember we did the two.
Yeah, we did the test, and so it was just waiting for the next sections to
It was
open
waiting
up.
for
Yeah.
her to unlock it. Yeah, and then
Okay.
I don't know why she did it like Thursday, I think at night, like after class, because she never emailed me during those hours. So you got them both now. You good to go, huh?
Yeah. Christine had like similar for her second shot. She like was at work and she got the second one because it was through work on base, and she had to go home early because she's like having headaches and she's like, this doesn't feel right. I'm like, yeah, go ahead, go home. And then the next day, it like on and off, really bad, and like she couldn't sleep through the night. It was pretty crazy.
Yeah,
But and then some people second shot nothing, and they're like, yeah, my arm was
yeah, that's what I
sore.
heard. Like maybe a light soreness
Yeah.
or something.
So I don't know. It's crazy.
That's cool. At least you guys got it, both of you guys. You know,
Yeah.
because I mean, they're trying to do that whole go anywhere type. You need to have it, you know,
Yeah. I don't know
on
how
the
I feel
two
about
course.
that. That's kind of crazy. Like, how much can you enforce with some people? Like, you can't make people eat healthy and like exercise
Yeah,
so that their immune system's strong, but you
yeah,
can make them take a vaccine to go travel. Like I don't know how I feel.
yeah. Not only that, they're talking about like what is it now? On the news today? I seen it to like go to like theme parks and stuff like that. You know, you're gonna have
Have
to
to
show your
show
vaccination
your
card.
wow.
Yeah, yeah,
That's
yeah. This
crazy.
the new one is a solving linear equations, and then it's variable on one side.
Okay, that's I think we've done that. Huh. Linear equations,
Variable.
variable on one. Yeah, I think that's like letters to one side, numbers to the other, or variables to one side, numbers to the other. I think we could jump right into that.
All right, I'll share it.
Maybe they'll try and throw in some word problems or something.
Yeah, for sure.
All right, let's see. Oh, there we go.
So
Passenger. So like the flat fee always for this, like the flat fee or the thing that you only pay once, that's always the number by itself. Like it doesn't have an x, a number
no
without
matter
the
what, right?
variable.
Yeah, you're gonna
Um,
pay that no matter what. So
yeah. So I mean, doesn't mean it's all by itself on the equal sign. It just means it doesn't have the x. But so like the Allied Taxi Company charges $250 to pick up a passenger. So 250 should be on its own. It shouldn't have. So the bottom two equations, they have 250x. Those are wrong
those
because
are off.
you're going to pay 250 just for getting picked up. Isaac was charged 296. So that's the total. So it's either of the first two equations, and you could like write that down and solve it, Or you could take their answer for X and then plug it in and see if it works. And then just test out both of them. Does that make sense?
So it'd be the first two, right? Because that's the plus the 250.
Yeah.
And let me read it again. Oh, it's 195 per mile.
Yeah. And that's why it's 195 times X, because X is the number of miles.
And then I could just put in any number, right? Or not any number, but
yeah, and they give so like those first two answers, they give you the number of miles. So like one of them's right and one of them's wrong. Like Isaac traveled 15.4 miles. Isaac traveled 12.8 miles. Like one of them is going to be right. So it's like you plug in that number of miles, times it by 1.95,
195,
and then add the 250 for getting in the taxi, and then see if it gives you $27.46.
So it's going to be the 12. Isaac traveled 12.
Yeah, the 12.8, the second answer.
Cool.
Yeah, of course it has to be like the word problems.
I know.
Do you have any ideas, or you want me to explain?
On his first run, he ran half a mile. He increased his workouts by adding 2 miles a month to his run. He wrote the equation model. The variable X represents the number of, I'd say, miles he runs, right?
It's not that. It's like a trick one. The equation, the function f of x equals 0.5 plus 2x, like that whole thing, once you're done calculating, it gives you the number of miles that he runs. But the thing that you input, the thing that you plug in for x, is not the miles that he runs. The key is he increased his workouts by adding 2 miles a month to his run. So if he increased the workout by adding 2 miles a month, that's the same thing as 2 miles per month, right?
Uh-huh.
Like if you, so like in 1 month, he's adding 2 miles. On the second month, he's adding 4 miles. On the third month, he's adding 6 miles. And it's like 2 times something. So 2 miles per month is 2 miles times the number of months. So the 2x is the 2 miles times some x. Well, that's going to be months. So it's actually the months that he runs. And then what the function calculates is the number of miles.
Oh, okay.
And it can't be the last two. The miles he ran the first day, that's already the 0.5. So that
It already
doesn't.
tells you that.
Yeah, it's gonna stay the same. And then the calories he burns, it doesn't mention anything about that. So yeah, the trick, it's a tricky one. Miles he runs and months he runs, but we'll see another one hopefully. Okay,
On the graph.
let me know if you want me to explain something or if you think you got it. I'll just let you.
I remember this one was because it's the f of x.
Mm-hmm.
Doesn't it's not like would it be 1.5?
It would be. Because it's asking for the input. Remember, the input is the same as the domain, which is the same as the x value. And f of x, that's the name of the red function. And g of x is the name of the blue function, or the blue line.
When they cross, right?
Yeah, when they cross is when they are equal. And the input for when they're equal is 1.5. Yeah. Cool. What would be the output when they're equal?
That means where it still crosses, right?
It still means where they cross, but not the x anymore. The output would be the y
it
value.
would be it'd be 1
Yeah.
and 1 in between 1 point. Well, it would just be 1, right?
It would just be 1
And-
because if you trace that, you see the dot where they cross. If you trace it over to the
Yeah.
y-axis, it hits 1 perfectly. At the dot, if you trace it over to the x-axis, it's probably like 1.5, and that's why
Yeah. Okay.
it's the 1.5 for the input. Which graph shows the input values for when f of x equals g of x. So first of all, that top function, f of x equals negative 1/2 x minus 2, that's the same thing as like y equals mx plus b. Do you remember that?
Yeah, kind of. I know I got it written down somewhere.
Well, if you can find that, then
Pretty easy to.
you could figure out the slope like super quickly.
Oh, okay. So it would be like the f x is the y, right?
Yes. So what would the slope be for the f of x equals negative 1/2 x minus 2?
So we're trying to get the so then it'd be -2, and then we do the 2 plus.
No, you don't have to do any like
Anything?
calculation or any work to be able to tell the slope. It's the m part, the y equals mx plus b. The m part is the slope, and the b is the y-intercept.
Slope is just the 1/2, right?
Yeah, but it's negative.
Yeah.
So
So that's all you got to find on the graph, yeah.
yeah, which one has a slope that's
Okay.
like,
The negative.
yeah, well, they're all negative slopes because the red one is f of x, and they go downwards. You just have to count from ones that land perfectly.
Would be this one here.
I think so, because you like if you start at that red dot, over 1, 2, down 1. Yeah, so the rise would be the 1, and the run is the 2. None of them, I think, no other ones.
One. See. Yeah, that's 1/1.
Yeah.
This one's in the middle. Yeah.
Yeah. So also another thing that I want to point out is you see the g of x The blue is all the same on all of the answers. When there is, so like if you look up at g of x equals -1, scroll up. There is no x value on the right side of the equation, right?
Mm-hmm.
So like on the top one, there's a -1/2 x, and so the -1/2 is the slope. This one, that doesn't even have that piece, right? So the slope is 0, which just means flat. If the slope is 0, it just means flat. And then the -1 is the y-intercept. There is no x part, so there is no slope, but the -1 is still there, and that's why it crosses the blue crosses the x or the y-axis at -1 on all of them, because I mean there's only the y-intercept for the g part. But yeah, that's it. Okay. So now they're talking input value produces the same output value for the two functions on the graph. Do you know what that means? It's a weird way of saying it, but do you know what it means?
Where do they, I know they meet here, right? But that's just the input.
Well, the input is if you trace that point down to the x, the input would be -2, right? The input is the same thing as the x value.
Yeah.
Okay, so to find the output, you go to that point and trace it over to the y-axis. So the output would be 1 if you went from the dot and then traced it over.
To the right.
So the output for both of them is 1. Actually, I'm going to take a picture of this because I want to explain some stuff.
Okay.
This is a good one to explain it on, I feel like. So let me see. But the two functions, this is a fancy way of saying where, like what x value do the two lines cross at? Because it's asking for which input value produces the same output value for the two functions on the graph. That's the same thing as saying which input corresponds to where the two lines cross. So what do you think the answer would be?
It'd be -1, right?
No,
right here.
where the two where the blue and the red crosses.
-1, or I mean -2.
-2, because they cross there, and then to find the input, you trace it down to the x. To find the output, you trace it over to the y. So, but it's asking for which input.
It's -2.
Yeah. So go ahead and save and exit because I want to share something on this.
Okay.
All right, so this is what I want to say. Like we were focusing on this point only, but I want to focus on some other point that I'll draw out just to make it. I'm going to call this point A. So for A, the input, what would that be, do you think, the input for point A?
So the input is it would be 1, right?
Yeah, so you just take it and then you trace it down. So the input to get point A would be 1. That's the same thing as saying the x equals 1. What would be the output?
It would be 4.
It would be 4. All you do is take it and trace it over. So that's the thing here.
Okay.
The output is simply whatever you get for whichever point you're talking about. Whichever point you're talking about, the output, you just trace it over to the y. So the output on this would be 4. That's the same thing as y equals 4, which is the same thing as g of 1, because g of x, like you plug in a 1 for x, and what comes out is 4. It's the same thing as saying that. If you plug in 1, the output is 4. Now, when it's asking which input value produces the same output, well, if you plug in 1, the output for g of x, which is the blue, is 4. If you plug in 1 to the red function, f of x, the output is -2. So 4 and -2 are definitely not the same thing. So when it says produces the same output, that also means where the two lines cross. It's just a fancy way of saying that. But always, for any particular point that you could plug in to get the input, you trace it to the x-axis, because input, domain, x's, those all mean the same thing. And then for that output, you trace it to the y-axis, because output, range, and y all mean the same thing. Okay. Consider the equation. Okay, so this is asking not to like solve the equation, but how, like what's the first step to solve the equation? Do you remember the first step? I think we talked about it once before.
Yeah, I need to get the p by, or the, it's not to get like the p by itself, right? Because there's two p's on there.
There's two p's, so that's important. There's two p's, but they're already on the same side of the equal sign.
We can add that p to the, and make it 4, or?
Yes, yeah, that's it.
Uh,
If they're on the same side of the equal sign, then you combine like terms, and since they both have a p, there's 3p, and then there's a plus p, which is the same thing as plus 1p. You can combine them. So if you have 3 p's and then another p, total, we have 4 p's. So you combine like terms when the variables are on the same side of the equal sign. So you said you get 4p, that's the only one that has 4p.
Yeah, okay.
And that would be the first step. What would be the next step? Starting from the answer.
And then you try to get the p together, right? I would try to get this -7 plus it, and then switch it over here.
So it'd be plus 7 on the left side, and then plus 7 to the 13, right?
Yeah.
And then you go from there. Cool.
So it'd be plus 7 here. When this is 0 out, right? Then you go this way, you're not going to here?
You always moving it to the other side of the equal sign. Like the variable is on the left side, so to get the p by itself, you first got to start with that 7 and move it over, and then deal with the 4 and move it over. Do you want to see it, or you're good?
No, I know. Now we got to leave that letter alone till we need it alone, right?
Yeah. I think this one, you need to solve the whole thing and write out the steps, and then you'd be able to choose. Because it's hard to tell without actually doing it. So I think you should write it out, and then if you don't know what to do, let me know, and I'll coach you through it.
So we're gonna do whatever's inside the equations first, right? But they have the letter in there.
Yeah, so you can't do, so whatever's inside the parentheses, that's what you're supposed to do first. But they're not like terms. It has the 7x and then the 6.3, so you can't combine them. So then the next step, parentheses, exponents, there are no exponents. The next is multiplication. So that's dealing with the 1.2. Do you know what to do with that?
We're gonna send it over to the 7 and the 6.3, right?
Yes. And that's called distributing. So that's one of the answers. Yeah.
And then we're gonna divide those, right? We're gonna actually.
Well, you multiply them. So like 1.2 times the 6.3, and then 1.2 times the negative 7.
$7.56.
That's what I got.
And then, negative 8.4.
That's what I got. So it's negative 8.4x.
That's X.
And then equals 9.38. So now what do you think you do?
So now we do. So that was multiplication. Now we're gonna do the adding, right?
Yeah. What are you gonna add?
The 3.5 to the 1.2.
It shouldn't be a 1.2 anymore.
Way, right? Because
it was a 7.56. Yeah.
Yeah, because that one goes. $11.06.
Mm-hmm. That's combining like terms because they both didn't have a variable. They're both just decimal numbers, just numbers.
So from this point on, do I do the because the x is still there, right? Negative.
Mm-hmm.
We're trying to leave that alone, right?
You leave that alone, so you leave the negative 8.4x. You leave that by itself.
So I'm gonna subtract 11.06.
Yeah, because it's already positive there. So then you subtract it to both sides. Yep.
Yeah, negative 1.68.
So 1.06. Yep. I think we've done all the steps. Like we haven't solved it, we haven't finished it, but I think we've done enough to choose three options.
To do the 3.
Yeah, because we did three things.
So the first one was distribute, right?
Mm-hmm.
Then we did combine the like whatever.
Yeah, combine the like terms.
Combine the like terms, and then subtract the.
And what would be the last thing that you would do to finish?
And try to get the. So then I would divide the 8.4.
Yeah, the divide negative 8.4 to both sides, right?
You get 8.4, yeah.
Cool.
Let's just do it.
Yeah, we can do that.
That way I can get back into it. It's negative 11.6. Divided by. I got 13166.
Wait a minute. What did you do? You did 9.38 minus 11.06?
Yeah, I thought I wrote that shit down. I guess not. Maybe I stopped. Maybe I didn't even do that. 9.38. Well, that was it was just subtract, right?
Yeah.
Yeah, because I think I got 1 point something.
Yeah, 1.68, but it should be negative 1.68.
Yeah, it was negative 1.68.
Okay. And so when you divide the negative 8.4, you're doing the negative 1.68 divided.
I don't know why I put 11.
Oh, okay.
So negative 1.06 divided by 0.4 negative equals 0.12. No, that's right.
8.4 negative equals 0.2. Is that what you said?
1, 2.
Sick. I'm gonna do it again because I got two different answers both times I did. So divided by 8.4 negative. So 9.38 minus 11.06. And we got negative 1.68, right?
Yeah.
And divide by 8.4 negative equals. I got 0.2.
0.2.
Yeah, you type in the negative 1.68 first. So 1.68.
0.
And then divide 8.4 negative
1.4 negative
equals.
0.2. Okay, I must have been typing something wrong.
You got it now, though?
Yeah.
Cool.
Those are those negatives. I might have.
Yeah, because you got to type them in like after you type in the number.
Yeah, and sometimes
I've
done it before.
Mustafa.
Mustafa soccer team.
Okay, so the $1,500 in profit, that'll be on the right side. That'll be by itself.
On the right side, right? So then it's 5. The number of students.
Yeah, 5 times n because it's $5 per student. So, and they all have 5N.
Plus how many students are no the DJ charges 200, decorators cost 100.
So that's a flat fee, 200 and the 100. That's a flat fee
Yeah, so
of
it'd be
300.
the third one, right?
It's not
No,
per.
that's
That's a flat fee. So none of the 200 or 100. Neither of those should have a variable on them.
So it'll be this one here, the second one. It's just the students, and then these are already added as a flat fee.
Right. However, they so this one's a tricky one so it's either the first one or the second one. It's actually the first one. Can you figure out why? With the minus 300 instead of a plus 300?
Because that's already a flat fee, so they're just minusing that from.
Yeah, they're trying to make money and to make a profit, but it costed them 200 plus 100. It costed them $300
already, yeah.
So that's taken
okay.
out. So they had to subtract that.
I don't know what. Why don't they just do simple math on here?
Well, this one, I think you can figure it out. You could solve it like using the steps, or you could plug in the answers and test it out. Like whichever one should work.
Equals 15. If I did just by doing the steps,
what would you do first?
Would be I would. Can I add the two x's together? Because
yes, because they're both. So they're both on the left side of the equal sign, and they both have x's. So you can combine them. You're combining like terms. So it's negative 10 plus 7.
This would be negative 3, right? Plus 1. Then we're gonna do.
And it equals the 37 still, negative, and then what?
Negative 1. Or subtract the 1, and it should be 36. So it's negative 3 x equals 36. So then we'll do. Now we're gonna add it, right?
No, because it's the negative 3 times the x when it's right next to each other means times. So you do the opposite of times.
Oh, we're taking we're doing that. Okay, never mind. I got it. So yeah, we'll do times 3. 0 out, use x alone. So we're gonna divide. 12.
So it'd be positive 36. Well, it would be positive 36 divided by negative 3, right?
Oh, yeah.
So then it would be negative 12.
Negative 12, yeah.
Number n is 8 to 15 less than 3 times itself. Ugh. These ones are ridiculous. Number n is added to 15 less than 3 times itself. I think if you like go slow and think about it, you might be able to figure this out. But it's just wording that they're trying. It's just like weird wording that they're trying to. But I can coach you through it if you want me to.
Number n is added to. Number n is added to. So it means less than just subtract, right?
Yes. So that's
Three
good. So
times.
15 less. It's 15 less, right?
Yeah,
So what are you subtracting when it says less? What are you subtracting?
the letter n,
Okay,
a
so
number, or the 3 times itself. So
hey, let's think about it like this. Let's just go through the very beginning of it. A number, and like I'm like blocking off like with my thumb. A number n is added, and I'm blocking everything else off. N is added. What do you think that looks
yes,
like?
the n's gonna be. So it would be like the 15 adding the n.
Yeah, like a plus n, right?
Yeah.
So it's either the first two already, because n is
Yeah. So it
added.
would be
Okay, there's n is adding in the first two answers. Okay, so n is
but it
added.
says, but the less than would mean it's a, right? Because it's a number, and is added
Yeah.
to 15
Uh-huh.
less 3 times itself.
3 times itself. The itself is referring to the n, so it should be 3 times n. And then 15 less. Like if you did what's 15 less than 25, that's the same thing as 25 minus 15, right? So if it's 15 less than 3 times itself, it should be 15 less than 3n, so it's the first one. Like this is one of the ones where like this is a fucking riddle to cross the bridge or something. Like otherwise
they want you to know everything.
it's I don't know, it's a weird one, but yeah, I think that's it.
That's a mix.
Cool.
Go. The next one.
What is it?
Distributive property.
So the distributive property was like the 1.2 times the 6.3, and then the 1.2 times the, like when it had parentheses, the 1.2 outside of the parentheses, we were distributing. I feel like they're just gonna put it into word problems. Do you want to try it, or do you want to go to that other section and try that next one there? Like it doesn't matter either way.
No, we can do this one. That way we can get closer to that.
Yeah, and then while we wait for opening a test, we can move on to
the next one.
Yeah. Okay, this is a lot of weird wording, but I think you'll get the answer. Uh, like, okay. So a variable expression, that just means like 3 times x plus 1. So 3x plus 1. That's a variable expression. 2x minus 1 plus 2x is another variable expression. It just means terms added together or subtracted, and they have a variable involved. So I'm going to give you an example. A simple variable expression, because it says Juliana begins to solve a linear equation that results in a variable expression set equal to the same variable expression. So I'm going to give you a variable expression. I want you to write it down, and then I think you'll be able to figure out the answer for this one. So I want you to write down x plus 3, so just regular x by itself, plus 3, and then equals x plus 3.
So x plus 3 equals x plus 3.
So without actually like solving with the steps, with the like the procedure, what I want you to try and do is plug in any number that you want for x on both the sides. You have to plug in the same number though. Like I think we'll immediately see what happens. Like if you plugged in 5 for x, what do you get on both sides? You get 8 equals 8, right? What happens if you plug in 0?
You get 0 for both.
And a 0 plus 3, so you get 3 equals 3.
Or it would be, yeah. I thought I was doing multiplication.
And then you plug in 1, you get what?
4.
4 equals 4. Each time you're getting the same number equals itself, yeah?
Yeah.
That means all of those numbers that you plugged in are answers. Like, normally when you solve for x, you get one answer. Well, here you can plug in a 5 and you get a true statement. You get like, 8 equals 8. If you plug in 0, you get 3 equals 3. If you plug in 1, you get 4 equals 4. That means all of those numbers work. And in fact, any number that you choose will output a true statement. Like you put in 100 and you get 103 equals 103. So,
that's one.
Yeah, there's an infinite number of solutions. You can choose any number that you want. And it's a complicated way of saying if the same thing equals itself, then it doesn't matter what you plug in. It's still going to be the same thing equaling itself. Like the x plus 3 equals x plus 3. Yes, of course that's true because x has to be the same thing on both sides, and the 3 is the same thing on both sides. The only way it would be different is if they said like x plus 3 equals y plus 3. Now that's like a completely different problem. But if it's the same exact thing on each side, then yeah, you can plug in whatever you want. And it still works. Okay, I think you can get this one. You just have to do distributing the 6 to the x and the minus 1 on the left side, and then distributing the 9 to the x and the 2 on the right side, and then you just go through variables to the left or whatever which way you want to do it. Or I could coach you through it, let me know.
Okay, so it'd be 6x and then 6 minus 1. We're not doing anything like multiplication, right?
You are doing multiplication. So 6x, that's the same thing as 6 times x. And then 6, it's not 6 minus 1, it's 6 times negative 1. So it becomes negative 6 or minus 6. It's like interchangeable. So on the left side, you should get 6x minus 6. Does that make sense?
Yeah.
Okay, and then let me know what you got for the right side.
Negative 6x.
It should be a positive 6x.
And then for the right side, I got negative 6, just regular. For the negative 1.
Yeah. So the next step you should write down is 6x and then minus 6.
Yeah.
Okay.
Equals. That'll be 9x.
Mm-hmm.
And that one would be 9x equals or plus 18.
Yes, 9x plus 18. And then now you have a decision to make for which way you want to move things.
It doesn't matter.
So like the normal, like the no, it doesn't matter which way you want to move stuff, but it's always like if you move a variable to the left side, then you have to move the rest of the numbers to the other side. It always has to be like the opposite for the numbers and the variables.
And I can't add the like terms because they're on the opposite side of the equal.
Correct. So you have to move them over. You can't add them or like combine them right now because they're on the opposite sides of the equal sign. So you have to move them over by doing the opposite.
So the 18, I'll do minus 18.
Okay. So you're moving the number from the right side because it doesn't have a variable. You're moving the number to the left side. So you're doing minus 18 and you're doing it to the minus 6, right?
I'm going to do it to the minus 6, right? Yeah.
Yeah.
It should be 12.
Well, they're both. So it's a minus 6, and then you're doing minus 18.
The positive, right?
No, that's multiplication.
Well, it's going to be a negative. It's going to be a negative 12 then.
Negative 24 should be. Because if you do 6 negative.
Oh, you're adding. Yeah.
Yeah,
right.
you're just adding those negatives together to make more negatives.
Are we adding or subtracting?
Well, it's negative 6 minus 18. You could do that in the calculator, and you get negative 24. Or you could do negative 6 plus negative 18.
Oh, okay.
And then you get negative 24.
Cool.
Because subtracting a number, like subtracting 18, is the same thing as adding negative 18. It's like the same thing.
Now to get the 6 alone, I'll just do the divide, right?
Not yet. So now you have 6x minus 24 equals
9x. Right?
equals 9x. So now you have to move the 6. So since you moved that 18 from the right side to the left side, you've moved the number over to the left side. So now you want to move the x that's on the left side, you want to move that over to the right side. And it's a positive 6x. So right now, it's like you could subtract it over. So you do minus 6x underneath the 6x. And then minus 6x underneath the 9x.
The 9x.
And since they both have x's, then you can like combine like terms. You can actually do the 9x or 9 minus 6.
It would be 3x, right? So negative 24 equals 3x.
Mm-hmm. And then the last thing is to get the x by itself. Like normally the x would be on the left side, but it doesn't really matter. Now the x is on the right side. You do the same thing though. You're still trying to get the x by itself. So what do?
Divide.
Divide by what?
By 3.
Yep.
So equals negative 8.
Negative 8.
So x equals negative 8. Seems like a long process.
Yeah.
But I mean, it's probably not.
Okay. So this one may be the easiest way.
Solution, right?
What's that?
Is it not 1?
It might be 1. It's definitely so. It's either for linear equations. Either there are no solutions, or there's one solution, or there's an infinite number of solutions, like we saw in that first problem. There's never 2 solutions for linear equations, and like we might get to something else later, but where they're nonlinear. But for this, I think the easiest way might be to just simplify the right side and see what happens. So like distribute that 3 to the 4x and the plus 1, but you leave the minus 2 the way it is just because it's outside of the parentheses. And then what do you get there?
Okay, so 3 times 1, I get 3. 3 times 4 be 12x.
So 12x plus 3. Now you don't need the parentheses. And then you copy down the minus 2 part.
Yeah.
What can you do with that stuff now?
Now I can do it doesn't equal 2, right? So then I can I do the 2 over to the 3?
So like yeah 3. Well, but it's a minus 2, right? So 3 minus 2.
Yeah. So
yeah, those are like terms, so you can combine them. So then what do you get?
1.
All right. So then the 12x is still there.
Get rid of that, right? So we're gonna do the divide.
Wait a minute. What do you have 12x plus 1, right?
Yeah.
Look on the left side of the equation.
12x plus 1.
That's the same idea as the first problem that we had. Those are exactly the same expressions. 12x plus 1 equals 12x plus 1.
So then we'll have
infinitely many solutions. Yep.
Many.
If they were different, then you could continue on and see what you get. But when they're exactly the same, that's infinitely many solutions. Because you can plug in whatever you want. You're going to multiply it by 12, and you're going to add 1. And you're going to do the same exact thing on the other side. There is a time when you have 0 solutions, but that's if you have like 12x plus 1 on one side and then 12x plus 7 on the other side. When the x's are the same, but the other number is not the same, that's no solutions. Like you'll never be able to find anything to plug in that'll make it equal on both sides. But we'll see that maybe when we get there. So this one, you have decimals. You could just distribute and combine like terms on the left side, and then distribute on the right side, and then like go forth and solve it. Or you could just plug in the answers that it gives you. This one, I think it might be easier to just plug in the answers and calculate both sides. Do you see what I mean?
Yeah, to the x.
Yeah.
But I would still have to distribute, huh?
Right. No, you could just do, so like if you plug in that 3, you could do the 3 plus 4 since it's not an x anymore. Once you plug in the 3, it's just a regular 3. So then 3 plus 4, you do the parentheses first, and then there are no exponents, and then you do multiplication. So then it kind of works out in steps.
7.
Yeah, so 7 times 1.5.
Negative 3.
So 10.5 minus 3 is 7.5, right?
Yeah.
Okay, now plug in the 3 on the other side and see if you get 7.5.
Okay, so I got 1.
And then times the 4.5.
Okay.
So that doesn't work.
Well,
7.5 is not the same as 4.5, so 3 is not the answer.
4 plus 4 equals 8. 12 minus 3 equals 9.
Okay.
So equal 2. So that one works.
Mm-hmm.
9 for each.
Yep.
Yeah, that one was easier to go down.
Yeah. So on this one, so it's either going to be 0, 1, or infinitely many. I think on this one, you have to distribute on the left side, and then you can leave it. And then you have to distribute twice on the right side. So let me know when you get the left side, and then I'll see if it's the same as what I got.
I got 0.75x plus 30.
Me too. Perfect. And then you say equals, and then you distribute the 0.35 to the first x plus 20. And then write that down, and then do the same to the other one.
Plus 7 plus 0.35 plus 7.
Mm-hmm. So now you can combine like terms on the right side. There's 2 terms with x's, and then there's 2 terms without x's, right?
Yeah.
So then combine the x's, and then combine the regular numbers, and then write that down.
On the right side, right?
Yeah, just on the right side.
0.7 x plus 7. Well, I can combine those two, right?
Correct.
Plus 14.
Mm-hmm. So on the left side, we have 0.75x plus 30.
Uh-huh.
And on the right side, we have 0.7x plus 14. They're not exactly the same, right?
Yeah.
So it's not the last answer. It's not infinitely many solutions. This one,
Be 2. What?
no, it won't be 2, but you can now solve it like the regular way. Nothing weird happens. It's not going to be 0 in this case.
There's going to be 1.
Yeah, it's going to be one solution, but you'd be able to solve it, and you'd be able to find one single number.
Okay.
After this, save and exit, and I want to show you something. All right, so for this, if we had one time 12x plus 1 equals 12x plus 1, that means there is infinitely many solutions because we had the exact same thing on both sides. If we don't have the same thing, if we have, so like that means you could plug in any number here and you're plugging in the same thing. Well, of course, you're doing the exact same thing to it. If I plug in a 5 over here, I'm going to times 5 by 12, and then I'm going to add 1. Well, I'm going to end up doing the same exact thing on this side. So, of course, I'm going to get the same number over here that I get over here. So that's why there are infinitely many solutions, because I can plug in an infinite number of numbers, and it'll still work out. When you have, like, say, 2x plus 5 equals, I don't know, x plus 6, when they're completely different, different on this side and different on that side, that means one solution. Because you just do like minus x, you just go through all the regular procedures and nothing weird happens. And you would get what? This is like a 1x, so x plus 5 equals 6. And then you do minus 5 minus 5, and you get x equals 1. And there's only one solution. And I mean, it just happened that the answer was also 1, but there's just one single answer. If I plug in a 1 here and a 1 there, then I'll get the same number on both sides. Like 2 times 1 is 2, and then plus 5 is 7. If I plug in 1 here, I get 1 plus 6 is also 7. That's the only way it'll work. If I plug in a different number, say I plug in 0 here, 0 plus 6 is 6. If I plug in a 0 here, I get 0 times 2 is 0, plus 5 is 5. So I get 5 here and 6 here. So it doesn't work. There's only one number that works, and it was this number. The other thing that happens, actually, let me show you something on this. Like when I have 12x, let me show you something. 12x plus 1 equals 12x plus 1. Here's what happens. If you tried to solve this, you would like maybe move the 12x over to this side, minus 12x, but it cancels out on both sides, and you get 1 equals 1. Well, of course 1 equals 1. This just means this is true, and it's always going to be true. So it actually, that means whatever you plug in here won't matter. As long as you're plugging in the same thing on either side, you're still going to get a true statement. It's like if you tried to solve it, this weird thing happens, but since this weird thing is always true, then it doesn't matter what number you plug in, as long as you're plugging in on the same side. That's that first case where there are infinitely many solutions. If you had, I mean, I mentioned this briefly before, but if you had, say, 12x plus 1 equals 12x plus 7, where they're almost the same, except for, so like the x part is the same, but the numbers are not the same. This means no solution. And here's the reason. If you were to plug in any number here, no matter what, this side, once you calculate it, will never equal this side. Like never. And if you try to start solving this, you could do it the same way, minus 12x minus 12x, if you're like moving it over. They cancel out, and then you get 1 equals 7, which is not true. So no matter what you plug in, 1 is never going to equal 7. Like if you plug in any number and times it by 12 and then add 7 to it, it's never going to be the same thing as when you plug in a number, times it by 12, and then add 1 to it, because you're adding different things to either side, the 1 and the 7, and those are never going to be equal. So this would be no solution. So these are all the 3 cases that could happen. When you have the exact same expression on both sides, the variables cancel out, and you're just left with the numbers, and those numbers will always be the same if you start out with the exact same thing on the right side as you do with the left side. If they're both different, like the x's are different, and I mean, if the x's are different and the regular numbers are the same, that doesn't matter. If the x's are completely different on each side, you're still going to get one solution. So like I could have made this a +5, it still would have been fine. You still would have, like if I did, let me change that real quick. If I had a +5, I should make it this color. And then all the same, like it would be the same thing. You'd still only get one answer. So as long as the x's are different, so minus, that would be just regular x plus 5 equals 5. Subtract 5, subtract 5. That's okay because I still have an x. And then 5 minus 5 is 0. So the answer is 0, but it's still only one single solution. So you still get a number. You still get an answer. As long as the x terms are different on each side, then you're going to get an answer. If the x terms and the regular numbers are the same on each side, you get infinitely many solutions. And if the x terms are the same, but the numbers are different, you get no solution. That's the third case, which we haven't run into yet. All right, now I'm done. We can move on to the next one.
Cool. Maybe they'll give me another solution.
What's that?
Maybe they'll give us one of the no solution ones.
Yeah, where the x's are the same, but the regular numbers are not. That's when you have no solution. Because there's no number that you'd be able to plug in that'll give you which equation has no solution. Okay, so you have to simplify. This one's going to take a while. But you have to simplify the left and the right side and look for when you have the same x term on both sides, but a different regular number term on both sides. Does that make sense?
There's no way of looking at it and doing it.
No. You have to simplify it a little bit.
Cool. Distribute the 4.
Mm-hmm.
4x plus 2.
Let me know when you're done with the left side.
I got 4x 5.
Huh?
So I got 4. Oh no, because it's 4. Yeah, so I got 7, right? The first step. 4x 7.
It should be, you're multiplying. So 4x is good, and then 4 times +3 is 12.
12, yeah.
And then it's positive, so you write plus 12. So 4x plus 12. And then plus 2x.
And then we subtract the 2, right? From the 2.
No.
Oh, no, it's a 2x. It's 2x.
Yeah, it's a 2x. So just leave that.
Add. Oh, that's it?
Oh, well, actually, what were you thinking? What's the next step?
I was going to add the like terms, so
it
would be 6x. Yeah.
6x plus 12, yeah?
That's cool. So the next one would be 12, 6x plus 12.
So what happens for that?
That one has intended solution, right?
Yes. So I move on to the next one.
So like this one has 5 plus 2.
So you distribute the 2, and even though like it's a 3 first and then the 2x, you do it the same way. So 3 times 2 would be 6, and then 2 times 2x would be 4x. So it would be 5 plus 6 plus 4x. And then what could you do with that?
We can plus the 11. plus 4x.
Yes.
And then we get to the other side. So it would be 3x
Mm-hmm.
plus 1x plus 3.
Plus 3.
Plus x, we can add that. So it'd be 4x plus 3.
Mm-hmm.
So that one doesn't have a.
So the x's are the same, right?
Yeah.
But the regular numbers are different.
So that'd be the no solution.
That's the no solution. Because if you subtracted 4x over to the left side, then you get 11 equals 3. Because the 4x cancels out on both sides. And 11 is not the same. It is never going to be equal to 3. So that one has no solution. No matter what you plug in, you'll never get the left side equaling the right side. Cool. How many solutions exist for the given equation? So you can distribute the 1/2, maybe change it to a 0.5. It might be easier to think about. It's the same idea if you change it to a 0.5.
X. Six.
Mm-hmm.
So I got 0.5x plus 6.
Mm-hmm.
So for the right side, we just do.
For the right side, it's already simplified. Like you could now solve, but this falls into one of the categories that I wrote down. Do you remember?
So it's going to be the same one. That's the last.
Uh-uh.
Well, none of the ones are different. Yeah, never mind.
Because you needed, so for the last one, we had the 4x and the 4x. But then the numbers were different. This one, as long as the x terms are different, you get one solution. And here, the 0.5x and the 4x, those are different. So you're going to end up with one single answer. Yeah. As long as the x terms are different after simplifying, then you'll get one solution. Okay, so for this one, you could either go through all the steps or you could plug it in and test it. But yeah, that might be faster to do that.
So I got the first one.
Yep, me too.
To be 27 plus 27. It would be 27 equals 27.
Yep. So the three cases are if you get exactly the same x and exactly the same number for both sides, the exact same expression on both sides, that's infinitely many solutions. If you get the same exact x term on both sides, but different numbers terms, then that's 0 solutions. And then if you get just different x terms on both sides, then it's one solution.
So like the left side here, I just do minus 13, and go to the 3, right? Or
no, on the left side, you don't have to simplify anything.
It's already
Yeah, You don't have
Okay.
to distribute, and you can't combine like terms. On the right side, you'll have to distribute and then combine like terms.
So it would be 3x plus 19 if I add the like
Oh,
terms
plus the 1.
after.
Yep. So the x's are the same, but the numbers aren't.
So we're gonna get the one solution.
The one solution is for when the x terms are different.
Oh, okay. This one, the numbers aren't the same, so it's 2.
No, it's 0 solutions.
Oh.
So when the x terms are the same and the numbers are different, the number terms are different, you get 0 solutions. Because if you start to solve it, like some weird stuff happens and you get like 13 equals 19, which is not true.
So the x terms are the same, but the numbers are different. Is when we get
no solutions.
0.
Yeah.
Did you record that one part?
What's that?
I don't know if you're recording.
Oh yeah, I'm recording. So yeah, I'll post it and show you or send it to you. Is again, like when it's simple like this, you can just plug in, yeah.
I got 66 minus 11 plus 35.
Wait, what? Say it again.
So if I plugged in like the 6, right, where the n is,
The positive 6 or the negative 6?
I did the positive.
Okay.
So then I distributed the 11.
Okay. So then 66 minus 11.
No, I got 66 minus 1.
Well,
or 11, yeah, because 1 times 11 would be 11, right?
Yeah, so then it would be minus 11.
Plus 35.
Mm-hmm.
Yeah. So now I just do the regular math because there's nothing through, right?
Yep.
Okay. So I got 90 equals 3n.
So let me double check that. Yeah, 90 on the left side. What do you get on the right side?
It would be 3 times 6, so it would be 18.
Mm-hmm. So it's not that one.
So, okay, I'll do it. So for the second one, I got 65 equals 12. So ain't that crap?
For which one?
Something.
The second?
For the regular 3.
Oh, for the regular 3. Yeah.
But I don't know. I think, yeah, that's what I got. But I should have been 65 equals 9.
I got 57. Hold on. I mean, it's still not right, but
Because I got 33 and then minus 3 plus 35.
so you're plugging in a regular 3, yeah?
Yeah, in the end.
So then you have 11 and then parentheses 3 minus 1, close parentheses, and then plus 35.
Yeah.
So when you have the number plugged in, I think you're still distributing the 11, right? So 11 times 3 would be 33, but then you have to do the 11 times the negative 1. So it'd still be minus 11.
That's what it was. So yeah, I messed up. Okay.
But if you're plugging in a number, you see when you have the 3 minus the 1, they're like terms now. So you can just do that since they're in the parentheses. You can just do the 3 minus the 1, and then it becomes a 2. And then there's nothing to distribute. You're only just multiplying 2 times 11. That might be
I got it. Yeah, that's my
way to do it.
So if I plugged in the negative 3, it would be times and 1 negative, right?
So it would be negative 3 minus 1. You could do that in the calculator. 3 negative and then minus 1 equals. So that would be negative 4. And then you do the negative 4 times the 11.
Equals negative 44.
And then plus 35.
Negative 9.
Mm-hmm.
And then we'll do 3. Negative 9. So it's the second one.
Yeah.
Yeah, so I was distributing the 11 every time.
Yeah, it still works if you want to distribute. You just have to do it to both. But when you're plugging in stuff, since they become like terms after you switch the n to whatever n equals, then you could just do the parentheses first and combine like terms, and then multiply and do all that. Oh, wait, I think we clicked on 10. Cancel. Did we do 6, 7, and 8? Oh, we did all those.
Yeah.
Oh, never mind.
Yeah, because we stopped.
Oh, it's just locked. That's why. I see. Yeah.
Yeah.
Okay. Cool. That one was a lot more like calculation, I feel like.
It'll be harder, you think?
But well, let's see what the next one is, because that I was just saying that the one that we just did was a lot more.
Oh yeah. There was a lot more to do.
Literal equations. I feel like this one might be, when it said like adding a number n 15 less than 3 times itself, something like that. Do you remember that?
Yeah.
I think that might be what this is. I'm down to try it if you are.
Yeah, I'm done. See what it is.
Yeah. Literal. Oh.
So this is like different.
Okay. Wow.
This ain't the same. Anything better?
Yeah, it's doing all the steps for solving, except for you don't have numbers. You just have symbols. -2. Yeah, I'm gonna say the answer and then we can pause it and I'll go over it. It's a lot of doing just all the steps, so you have to like be good at doing the steps without knowing what numbers come out of it. So
Okay.
let me get it real quick. Hold on. Wow, there's a lot happening on this one.
It's not good to get run out of paper.
Yeah, hold on. Yeah, lots is happening. So the answer is the first one. If you click on that, then I could explain it to you after you save and exit. I took a picture, so you're good. Okay, so first, like when we're solving, so I'm gonna make something up real quick. If we're solving, like, um, if we're solving something like this, you want to get the x by itself. So I'm trying to move this 5 over to this side. So you would subtract -5, -5, and then you get what 10 equals 2x. And then if you're trying to get the x by itself, you divide by 2. You're getting this stuff off. You're dividing by 2. This is going to be a big jump, I feel like. But that goes away, and then you get just 5 equals x. So I'm going to try and reference that when we see this problem. I think it's going to be weird, but I guess we'll try it. So on this one, we're starting out with this equation. S equals 2 pi r h plus 2 pi r squared. So we're starting out with this, and Marta is solving the equation for h. That means she wants to get h all by itself. So she wants to get h all by itself. That's the big part. Oh, it's going to be so weird. You see how, like, there's 2 terms on the right side. I mean, there's a bunch of things, but there are 2 terms. This huge term and this huge term. They're both on the right side. This is the only one that has h. So I'm going to deal with this one first. The same way that this had 2 terms, and here I was solving for x, so I dealt with this one first by moving it over. That's what I'm going to do here. Oh, this is going to be weird. So the first thing that I'm going to do is deal with the term that doesn't have the h, and I'm going to just do the opposite. It's adding 2 pi r squared. It's positive. So I'm going to do the opposite, minus 2 pi r squared. And I do it to both sides, minus 2 pi r squared. But this is an s, and this is an r squared, so they're not like terms. The only thing I can do is write down s minus 2 pi r squared. 2 pi r squared. This canceled out, so all I'm left with is 2 pi r h. I pretended like this whole thing was a number. If this was plus 37, then I would do minus 37 minus 37. I just pretended like it was a number. So far, does that make sense?
Yeah. So it's pretty much kind of the same, but
it's the same steps except for you're not dealing with numbers anymore. You're just dealing with a bunch of symbols. The next thing is I'm going to pretend like all of this, because I'm solving for h. That's the only thing that I really want to get by itself. So I'm going to pretend like this is also just a single number. Like if I had 36x equals 102, if I had something like this, I would divide both sides by 36. Divide both sides by 36. And that would get rid of the 36 and then leave me just with x and whatever that is, I don't know. But the same way, I'm going to get the x by itself. I'm going to do the same thing for this. Just pretend like this is a number, so I'll divide by 2 pi r. And then since there are two things on this side, this thing and this thing, I'll divide 2 pi r and 2 pi r. So I'm dividing everything. It cancels out here because I have a 2 and a pi and an r. Cancels out. Here, I have s, 2 pi r. Nothing cancels out for this term. Nothing cancels, so I'm just going to write it. For this one, well, then I have minus because of this minus here. The 2 cancels. The pi cancels. And then the r squared. R squared just means r times r. So if I had r times r and then an r on bottom, one of them cancels, leaving me with just a single r. So I just have minus r, and then that equals 2 pi, whoops, just equals h because all that stuff cancels out. That was a lot. Does that, like, do you have questions on that?
Yeah, it seems like the only thing is I ran out of paper, so I have to go in Walmart.
Oh, you don't have anything, right?
No, I should have bought some, but I just ran out of the last 2. Yeah, I can write on the front of the newspaper.
Do you want to pause this and then like just continue later?
Yeah. If you want to tonight or if not tomorrow, that's up to you.
Yeah, we can do tonight.
I'll go right now though, just get it all. Yeah, let you have dinner.
Yeah, I could do tonight. I think so. Just like at 8 o'clock.
Yeah. Just text me if you can.
Okay, sounds good.
I'll do the same thing. If you can send me the video, then.
Yeah, I'll upload it right now and then I'll send it to you.
Okay.
All right,
it does
bye.
seem like a lot.
Yeah, it is a lot. I feel like you definitely need paper to work it all out because I was trying to do it in my head at the beginning and then I'm like, I need to write it down. All right, I'll text you if anything comes up.